Welcome back to my YouTube channel. Enna Alfred is my name. Please subscribe to my YouTube channel and enjoy technical drawing lessons. The link is below there and my contacts are there as well. We are looking at focal spheres, and in this case we are going to use the focal spheres to determine the directrix, vertex and the focus of the parabola. And as you can see, we have our heading here as parabola. Now we are going to have an example which will guide us in the question. So we are having an example. We have the cone having the base diameter 60, height 80, and the sectioning line parallel to the slanting edge, and of course that gives us the parabola when you draw its true shape. The first thing we need to do is to copy the figure as per the dimensions. So I've copied the figure as you can see it here with its sectioning line. So we start with obtaining the three parameters: the directrix, vertex and the focus. What we do here, the first thing we do is to bisect the angle formed between the cutting plane and the cone, and the angle there is that one. So we bisect to get the center here, and when we get the center, the aim is to inscribe the circle which will work as the focal sphere. Having obtained the center O, we drop the perpendicular to the slanting edge of the cone. We can put it this side or we can put it the other side. The aim is to get the perfect radius of the circle which will act as the sphere. So having dropped the perpendicular, we can now inscribe the circle at that point O, and that gives us the focal sphere. As you can see here, this is our focal sphere. Now what do we need to do? We need to obtain now the three parameters. Let us first obtain the focus. We are going to drop the perpendicular from the center O to the cutting plane, and when you drop the perpendicular, it will give you the point around there, and that point is the focal point, as you can see. So we have the focal point obtained. Then the point at the point of inscribing the circle, it gives us the vertex. As you can see there, the vertex is also given. Now what I've done here, because this is a parabola principle, the VF is equal to dV, so we can put direct using that principle, as you can see there. However, you can as well draw a parallel line to the base of the circle through the point where this perpendicular is cutting the slanting edge, and when you draw the line parallel through that point, it will give you still the same point, directrix. And so I've put that line since the directrix is a straight line. So we have obtained the directrix, the vertex and the focus. But this being a sectioned figure, we need also to draw the complete plan and the true shape of the figure, which will cater for the parabola itself. Now what we do here, we divide now the circle into 12 equal parts, and when you divide, you get those divisions like that. Like we have now 0, 1, 2, 3, 4, up to 11, or back to 0. Now what we do, we join the diagonals to get those points joined like that, and then Next thing is to project those points on the surface of the circle to the base of the cone itself. And having done that, we are now going to project these very points to the apex of the cone such that we obtain the cut surface here. For example, I'm going to use the point 6. When you project point 6 to the apex, it will be still on the slanting edge. So I go and get the point where the slanting or where the cutting plane is meeting the line I've drawn, and then I project it downwards to give the point for 6. I can also take another point like 5, 4, 3. So when I take 5, it will give the same principle and it will give you the 5 and 7. When you take 4, it will give you the point 4 and 8, as you can see. Then we can also take the point on the base of the cone where the cutting plane is meeting the base, and we project it downwards to give us new points A and B. Having obtained that, there is also another point we have not plotted, point 3. Now point 3 is a straight line. When you follow it, you cannot obtain the points here. So what we do, we are going to project a line horizontally through that point where it is cutting the plane. And when you do that, you get that line drawn horizontally. Now when you draw it, it must reach the slanting edge. At that point, we can project it downwards to the center line of the circle. And having obtained that point, we can now project the arc using the center of the circle so that we can obtain 3 and 9. What we can do now is to join the curve through those points A, 3, 4, 5, 6, 7, 8, 9 back to B. And that is the curve, or that's how you see this sectioned part of the cone. You can outline it to have it perfectly seen, as you can see there. So you have drawn the complete plan at that point. It is showing that this part of the cone is cut off, so you only have that. Now let's see how we can draw the true shape, which will be our parabola. What we do here is very simple. On the slanting line, which is sectioning the cone, we draw lines at 90 degrees at each and every point where these lines 1, 2, 3 are cutting the plane. And when you do that, you have the line, you have the line, have the line, have the line, like that. They are parallel to each other, or they are 90 degrees to the cutting plane. We can now put our line XY at any point away from the figure, but it must be parallel to the plane XY, and that line is drawn at any position. Make sure that it's at 90 degrees as mentioned. Now what we do, we are going to plot the parabola at that point. How do we plot the parabola? We are going to pick the heights. Like for example, here we have the height from this center line to point 3. We have the height from here to point 9. So when you pick that height, I've called it H3, H3. You pick that height, you go and mark it on the true shape diagram. And when we are marking, we pick the height, we bring it there. So you have H3 marked from the center here to that side, from the center here to that side. After that, you can also pick the next height. I'm demonstrating with HA and HB. So you pick the height from this point to HA, you follow the line, come here, you mark it, and then you mark it there. You repeat the same with other points, and you obtain a curve like that, and that curve is a parabola. Having drawn that, now outline your figure to make sure that it is seen properly, and we now project the focal point, the vertex and the directrix to the diagram to represent them, that we have our focus, the directrix and the vertex like that. And that is how you deal with the parabola. You have completed the figure, or you have drawn the figure with the help of the focal sphere. Now, let me guide. F in the question represents the focus, V represents the vertex, D represents the directrix. Then we can get the eccentricity of the parabola from the principle that we have eccentricity as VF divided by VD. But our VF is equal to VD, so we have 20 millimeters over 20 millimeters, which is equal to 1, and that is the parabola. Thank you for watching. Please don't forget to subscribe to my YouTube channel. Enna Alfred is my name. The link is below there, and the contacts are there as well. Thank you.